Hello and welcome to Amulya's Academy YouTube channel. Today in this tutorial, let's write a Python program to implement jump search algorithm. To write this program easily, I'll divide my program into three parts. One is take inputs, here a sorted list of integer number and a target element. Next, we'll call jump search function. We'll perform searching operation. This function will return position of the target element if it is present, or it will return -1. Then we'll print the output using that returned result. Alright, first let's take the inputs. In the Python file, you can take list directly like this, and here you can mention the numbers, or we can take the user inputs, or if you want to take user input, you can take like this or like this. Alright, next let's define a function for jump search. Def function name jump search. Then here I'll take a list and a target element. Done. Colon. And inside the jump search function, first we need to calculate the jump size or block size or step. To calculate that, we'll take the square root of the list size. So jump size is equal to square root of list size. So first here, let's calculate the jump size. I'll take a variable called step, and here we need to find the square root of list size. For that, first we need to know the list size or the number of elements present in the list. I can use len function to calculate that. So I'll take a variable and I'll use len on list. Then we need to calculate the square root of that. For that, I'll use math module. So first I'll import that, import math. Then here I'll use square root. Now here we want only integer part. Here step is an integer number. So I'll use int function to convert that result to integer. So for example, if n value is 5, math.square root will get square root of 5 as 2 point something. So we want only 2. That's why we'll use int function like this. Alright. Next, we need to compare the last element of block and target. So to do that, we need target element and last element of the block. Here target is an input. But how to find the last element of block? For example, here in this, target is 90. First, we need to compare this target with the last element of first block, that is 5. How to access 5? Here we can write like this. If our list name is numbers, then we can write numbers of step. So here step value is 3. So we'll get numbers of 3 minus 1. So I'll get 2, right? This block size is also 3. I'll add that. So we'll get 6. 6 minus 1. We'll get this index. We can access this element now. To access this element, we can write like this. Generally, to get the last element of each block, I can write like this. Numbers, step minus 1. But what about the last block? We know that if the list size is not a perfect square, then the last block may contain fewer elements, right? For example, here you can see. Here, the length of this list is 10. It is not a perfect square. So in the last block, we'll get only one element, right? So now how to access the element in the last block? We don't know that how many elements are present in the last block. For example, here if we use same formula, then we'll get index as 11, right? But here the element is present in this 9th index. And if I try to access the element present in the 11th index, it will give you error, right? So how to solve this problem? For this, we'll use minimum function. We'll write like this. So here, for the other blocks, step is always less than n value, right? That is the length of the list size. Here you can see that. For the last block, when step is greater than n value, that is length of the list, to access the last element present in the last block, we'll write like this. That is nth index minus 1. Okay, now we know how to access the last element of each block and how to compare the target element and block element. We need to check whether target element is greater than the last element of every block, right? If target is greater, then we need to go to the next block. So what we need to do? We need to do this again. We need to compare the last element of the next block with the target element. If target is larger, we need to do this again and again, right? So for that, I'll use a while loop. I'll use while and I'll compare the last element of block with the target element. If target element is greater, then we'll go to the next block and we'll again compare the last element of that block with the target element. So we can write it like this: while numbers, that is the list name. Here I'll use minimum function because we need to access the last element of every block, and to access the last element of last block as well as other block, we'll use this minimum function n and step. If step is less than n, then it will take step value like this. If step is greater than n, then it will take n value here, and here -1, right? To access the last element of every block, we'll use this formula. Is less than target. If target element is greater than the last element of the block, then what we need to do is we need to go to the next block. For that, what we need to do is we need to upgrade this step value. For that, I'll use step is equal to step plus, I'll again use this. So what are we doing here is, so initially for this block, step is 3, right? For the next block, step is 3. So total is 6, right? So for that, I'll add like this. Alright. Now, control again go here. It will compare the last element of that block with the target element. If target is greater, then we'll again upgrade the step value. Okay. What if target becomes less than the last element of the current block? At that time, we need to perform linear search on that block, right? We need to apply linear search. For example, if target is 90 here, we need to apply linear search on this block, right? To apply linear search, we need to know the first element, or we need to know the index of the first element of this block, right? For this, what we need to do is we need to take a variable and we need to keep track of the first element of each block. So to do that, what we need to do is we need to take a variable like this. Initially, it will point to the first element. Next, here we need to upgrade that in each block. That is, here we'll take a variable. Initially, it will point to this. Okay. Then we'll compare the last element of this block with the target element. If target is greater, then we'll go to the next block, right? So now that variable will point to the first element of this block. Next, if we go to the next block, then it will point to the next block. If the target is 90, this condition becomes false. So target is here less than the last element of this block. So now we need to apply linear search on this block. To apply linear search, we need to access the first element of this block. We can do that using this variable like this. Now we can perform linear search. So this is the importance of this variable. And also here, if this becomes greater than or equal to length of the list, then we need to return -1. That is not found scenario. For example, if the element is not present in this list, so first we'll compare the target element with the last element of first block. Here target is greater. Then we'll go to this block. We'll compare 56 with 130. Target is greater than this value. So we'll go to the next block. Here 123. We'll compare 123 and 130. No. Then we'll go to the next block. Here 125 and 130. No. Now here you can see we don't have any elements to check here. So we need to stop. For that scenario, we'll use this formula. When previous or this value becomes greater than or equal to n, then we need to return -1 and we need to stop. So now we are done with the while loop. This is to check when target element is greater than the last element of each block, right? Now, if we get a block where target element is less than the last element of the block, then we need to perform linear search, right? For that, I'll use for loop. We need to take the every element of that block one by one and we need to compare it with the target element, right? To get the element one by one, I'll use range function like this. Start from this, the index of the first element, and to get the index of the last element, we need to do this because what if our block is the last block? Then if target is equal to numbers of I, if target is found, then return that index like this. If not, we need to return -1 outside the for loop. Here, if target is not equal to first element of that block, then go to the next element, compare. If not, then go to the next element, compare. After comparing every element of the block with the target element, if target is not found, then return -1 here. Okay, so now we are done. Here this jump search function includes 3 parts. First, we need to calculate length of the list, we need to find step, and we need to take a variable to keep track of the index of the first element of every block. Then here we need to compare the target element with the last element of each block one by one. If target element is greater than the last element of the block, then go to the next block. We'll write this code for that. Here, if target is always greater than the last element of every block, and if it is not present in the given list of number, this condition will become true, so it will return -1. If this condition becomes false, if target is less than the last element of a block, then we need to perform linear search on that block. So for that, we'll use this formula. If target is not present in that block, then we need to return -1. Alright. Next, we need to call this function here, and this function will return a result, right? So we'll store that in this variable, and if return result is not -1, then we'll print target is found message. Else, if result is -1, then that means target is not present in the given list of numbers. You can print that message. So we are done. Let's save this and execute this. 50 is found at index 4. Now if I take 60, which is not present here, if I take 35, okay, so this is how we can write jump search program. So that's it for now, guys. Thank you for watching. Don't forget to subscribe to my channel. I will meet you in next class. Till then, take care.